Okay, so everything is now recorded. Um, okay, let me start. So this chemistry, you are doing this because you are intending to be a scientist or work in different field of chemistry. So in this chat, you'll be expecting things like you need to be thinking like a scientist, all right? Sure. So what happens is that you as a scientist, first of all, there's something that there's what we call science mind, whereby you are always like you want to find out every problem you see, everything you see around you, you want to find the solution. That's what we call scientific mind. So, as a scientist, um, there are what we call scientific methods, all right, of discovering things. Is that clear? So, in as much as you'll be discovering a lot of things, there's what we call scientific methods. All right. So, what are these scientific methods? These are just methods used by scientists to discover or come up with a solution or suggestion or just solution for a certain observed problem. So, you'll see a problem, then you use these scientific methods and come up with a problem. I mean, with a solution to that problem. All right. That's the reason why you find that there are a lot of things like are being discovered, like even the use of AI. Yes, we had Google. Google, it wasn't there before as well. People could just use that books. But again, Google came and we are researching now using Google. So from there again, other people again have discovered the use of AI. You see, like they have seen already, there's already something working, but they still want to advance. Now, what do they use? They use what we call scientific methods in discovering these problems. All right. Sure. So what happens is that first you observe a problem. All right. In these methods, we have defined the methods. These are methods used by scientists to come up with a solution for a certain observed problem or phenomenon. So what you are trying to say is first you observe a problem. So say observation. All right. You observe first. So observation. By the way, is the which one is good? The red ink or the black ink? Okay. So the other thing that you do after just observing the problem, first of all, you identify which is just observing, right? Then from there, you develop what you call hypothesis. So you come up with what you call hypothesis. I will explain what is this is. So you are here now. Let's say you want to discuss why plants do not give. I mean, they don't give fruits like during dry season. You want to see the case of mango. You want to explain that, okay? You want to start that, yeah. So first of all, you observe that to say no. Why like the mangoes do not give they don't give fruits like during dry season. So then what you are going to do, you develop what you call a hypothesis. All right. So it's just a tentative guess, or what can I say? I can say this is just a scientific assume as like you just assume something to say okay, this one is relating to photosynthesis thing. You get it? So you relate. A hypothesis is just a educative guess. All right, to say you can refer to something like previous knowledge. That's what we call hypothesis. I just want to make you understand. Yes, like something whereby you refer to say, okay, the reason it could be maybe because of photosynthesis. It's just an educative guess that you make based on that phenomenon or a problem, which is under observation. Is that okay? Sure. So from there, what you do is, okay, you have done the hypothesis. You'd say, okay, I'll use this concept of doing the starch stuff like that. You get it? So that is from a educative guess, which is you say photosynthesis is my actually reference for this problem because you can't just start. Even when we are developing cars, we use previous knowledge like to say, okay, we know how to make tires. So the only thing we can change maybe is the engine. You get it? So that's why. Yes, yes. So that's what we call hypothesis. So I just wanted you to make it, I mean, to have a clear understanding of what it is. Otherwise, you can define in many ways and you meet different books with different definition, but all in all, the understanding is very important so that you write your own English. All right. So from there, then you say, okay, since I've made this guess to say this problem, it could be from what we call photosynthesis. Then what am I going to do? All right. So I need to experiment this. So you conduct an experiment from there. Sure. So some books you find that there are a lot of stages. They will say observation, then you come up with this, then a collection of data, then experiment. Some books, but this one, because for you to go to do the experiment, you've already collected the data, isn't it? Sure. So you are going to experiment. Then once I mean, the result that you are going to find after experimenting, now those results, if like after just let's say they have obeyed and they have been produced, let's say an equation, okay. Okay, before even that, you have just seen that the result have you have concluded with the results, and you try maybe again twice, it's giving the same. Then you are now free to call it a theory. Is that okay? Yes, based from the result that you are going to make, those now they will give what we call a theory. If they have been reproduced, sure. So you don't just come up with it. That's why theories, like we have what give me any theory that you know. Sure, sure. So that was just done by someone, you get. So there's just someone like who did that. So it's one person who did that. Now the result, like when he tried to do that, let's say the kinetic theory of matter, the gas particles, Brownian motion. So the guy tried in small particles and he saw that okay, the same thing is happening again. He tried on a different instrument. It's true. He got the same zigzag movement of particles, gas particles. So that's why he developed it to say a theory, kinetic theory of matter. You get. So this theory, sometimes someone will call it a model. Is that okay? Sure, sure. So that is it. So now, as we do this like theory, since you have done it in Zambia, suppose, then again in someone in America, they will use the same theory, suppose, they will do it again. Okay, they are going to do it. Then once they perform and get the same results you got, then it's now ready to be called a law. So a theory will be developed into a law when it has been tested, like, and giving the suppose even that equation for y is equals to mx plus c. This is now a law. Like we have law of motion, law of Shan. So yes, those were tested frequently from different people, and they concluded to say, okay, since now it is working in different, let's say here in Zambia it's very cold, I mean very hot. You go to Russia, it's very cold. So and if the same experiment is giving the result, then we'll be able to call it a law. So a theory would be now developed into what we call a law. So a law is actually a summary of all the theory based on certain phenomenon or a problem. Okay, producing the same results. Yes, I just wanted you to understand this. That's how you meet these terms: hypothesis, theory, law. Okay, so this law, it will be a mathematical expression. Always it will be developed into a formula. That's why you find that there's a law of the equation of motion, the equation of what? Those are equations. By virtue of them having that equal sign, meaning that it's a law. Okay, you find that under theory, these are just suggestions, but under a law, you find laws like first law of motion, second law of motion. You get there is always an equal sign in that relationship. So that's what we call a law. So a law is actually a mathematical expression showing the relationship between variables. Which are variables? These things that are changing. Okay, it's just showing the relationship between two variables, two or more variables. That's what we call a law. Is that clear? All right. So those are the things like writing definition here to waste my time. That's why I'm trying my best to explain from here. Is that okay? Yes. So then from there, I don't know if people are making noise where I'm seated here, but I guess my headset are canceling the noise. It's not that much as I'm talking. Like, which one? Are you getting the noise in the background? All right, that's great then. Okay, so now, yeah, this is just introduction. I was just trying to show you scientific methods. We have defined them and also terms that are found under that. And we have now explained. Let's go to what we call matter now. Of course, we know matter, but this matter is very important that we know some things actually that fall under it. So yes, there are questions. You'll find questions under this. All right. Okay, let me just grab this. All right. So, what is matter? If I'm to ask, though, it's actually not important, but it's just important. I mean, to know it, like to recall. Yeah, even as so that we appreciate what we are studying. What is matter? All right. So, anything. So this will be a thing that has mass and what volume to say. Yes, so it will be something that has mass and volume. So this thing, you find that it will be actually composed of things. It has also atoms or just the color of it or whatever composition it will have. But I'll ask you to say, is that like all the composition or all the atoms found in it, are they the same or they are not the same? So let's say no, they are not the same. Then here we'll say yes, they are the same, right? So this matter most is what we call a mixture, all right? Because it's made up of something. So a mixture is can be a mixture, it is actually made up of what, two things and above, like two or more, right? Yes. So this is the thing we have. Is it made up of the same thing? If yes, then that will be called a homogeneous mixture. If no, that will be called a what? Sure. So that will be called a heterogeneous mixture. Let me just say hetero. All right, that is it. So when we come to homogeneous again, what we need to know is that um um let me do this. Since this is homogeneous mixture, again I can ask you the question: is it homogeneous pure or homogeneous mixture? You know, there are homogeneous mixture such as water and milk. You get yes, that will give you homogeneous. Why? Because the thing you're able to see them, you're able to see them to say um you're able to see them to say, okay, there's milk. I mean, there's this mix I have here, hetero. Let's say it's sand and water. Yes, it is hetero. I'm able to see by just virtue of my eyes. Then this one I can't tell, but I know it's a mixture. You get right? So, so does it have also? Let me do this. Is it also like? Does it have like a combination of things for it to be homo? Does it have? Suppose it has. Let me say yes. I then here it say no. Okay. The case of no, it could be that I asked you to say, does it have a composition in it? Like if I say no, meaning that let's say it's just water, you get right? Like yes, throughout. Then if I'm saying it doesn't have, then I'll say, okay, example of it, it can be yeah, like water itself or just milk itself without any adding anything. You get ka? Yes. So if it doesn't have that combination, it is now what you call a pure substance. Is that okay? Sure. So pure substance. So since it's a pure substance, then here this side I'll end because I can't develop more information about it. If I say okay, this one it has variable compositions. If it is variable composition, it will still remain as a solution or just a homogeneous mixture. You get my point? So here I'll end. It's still homogeneous or solution if it was in water form. Okay, it's a solution because solution is more like let's say sugar and the water. They'll make up a solution. And you won't tell. It will be a homogeneous mixture. Why? Because it will be just zig, like looking at that color brownish. Hi. You won't differentiate that there's something inside so long as the sugar is melted there. So I said it's a pure substance, yes. So now, it being a pure substance, can it be separated? Can it be separated? If I say yes and also no, can it be separated? Okay, if it can be separated, then that will be what? That will be what we call a compound. All right. So if it can't be separated, is what? No, you. What is an element, by the way? Yes. Okay. In short, it's something that is made up of the same type of atoms. That's thing that can't be split into two. You get? Sure. So that is what we call an element. So it will be an element. Is that clear? Sure. So now I can now give you these terminologies. Um, it's important. They ask in these exams, like, first thing that I would define is what we call a substance. All right. What is a substance? Okay, it can be any form of matter. Then again, let me also call a term called mixture, of which I've already like tackled most of the important part. Then and also they say this one we developed into homogeneous and also heterogeneous. I think these are enough. Yes. So and also an element. Then from an element, a compound, just to understand. All right, so let me just like again, yeah, I don't have time to write because of the time, and also we just have. You tell me the time we have started. We just do maybe 1 hour, 40 minutes, just like this is online. So do it even in just 1 hour. Okay. All right. So a substance, we say this is what? Sure, this is just a form of matter, right? Yes, like water, a gas, let's say sugar, gold, the oxygen, those things, those are just any form of matter is called a substance. We'll be studying the term that we'll be using that for that thing, whatever thing it's called a substance. Now that substance, we'll see it again, whether it's a homogeneous mixture, stuff like that. That's where I'll go now to homogeneous, I mean to mixtures, hetero or homo. We have explained this, right? And also an element, that thing that is made up of same type of matter. Then a compound is substance made up of two different things. All right. Is that okay? Different things. Suppose, e.g., ionic compounds, you find that let's say sodium, sodium, and also chlorine. Okay, these are ionic compounds. It's a compound in short. Then I can also add what we call now a molecule. Okay, so a molecule, it can be a compound, or I can say a molecule can be a mixture or a compound. So this molecule, it can be made up of same atoms or different atoms. Okay, so we can have, let's say, O2 molecule. Get, again, I can say we have carbon dioxide molecule, H2O molecule. You have seen, so it can be made up of two, I mean same or different substance. So you find that a molecule can be a compound can be a molecule, but not a molecule being a compound. You have seen, because this guy, it will be just different things, but this one, this molecule, it will contain even different things or same things, so it doesn't matter. Sure. So those are terminologies that we need to understand. Just to understand, defining won't be problem. We don't have to master the certain definition we find in books. Just to understand, then will be well and good. So the same matter we are from discussing, it has what we call properties. Is that okay? So properties of matter. All right. So um, the properties of matter actually can be classified as the um, first of all, it can be physical or chemical. All right. So say, let me start with physical property. So physical properties, what are these? We explain them. All right. So what are physical properties if I'm to ask? Sure, sure, sure. Suppose we are to boil a certain solution. Let's say we boil, all right? E.g., let me say e.g. boiling. Okay. What else? Melting. Good. Sure. Etc. So again, we can also talk about what we call chemical properties. So what are these chemical properties? If I'm to ask again, because I've given an example. So it's just the opposite, I'm sure, in defining. It's just the opposite of what you have defined at first. So what could be these chemical properties? What are these? Chemical structure. All right, in line with that, yes. So it will change the chemical structure and also it will change just the chemical composition sometimes. All right. So chemical properties, these are properties that we observe when there's a chemical change. Suppose you burn, let's say, a paper, you find that it will turn into an ash. Are you going to reverse? No. So you find that these chemical properties, they can't be reversed once performed. So they affect the matter completely. And they are the opposite to physical changes. Physical changes is, e.g., breaking a glass. A glass will still remain a glass, right? Yes. But burning something, like you burn something, like let's say a paper, that will change the composition and also the structure, like you said. Okay. So let's say you are burning, let's say, hydrogen with the oxygen, right? You burn something in the oxygen. So you find that you make what you call H2O, right? You're making water in short. Yes. So those are the things we talk about. So, but these properties, the same properties that we have seen, these properties, they can be classified again into extensive property or intensive properties. All right. So we are going to measure these properties that we have in just two different ways. These properties that we have, we'll measure them again into two categories. Two categories um, of matter. Let's say properties of matter. All right. I don't like writing. It's taking time. So let me just change also the color. All right. Okay, that is it. So these properties now, um, there's what we call extensive and intensive properties. Is that okay? Sure. So we have what we call extensive. So very important, this thing, they like asking. I'm also giving an example, defining and also giving an example. So we need to pay attention. These are sensitive things that will make you even to score what you want. So these are what you call, like, we have intensive and extensive property. All right. So maybe you have an idea what is an extensive property of matter. Okay, so okay. So when you say extensive property, all right, These are just properties of matter that depends, the extensive external part, something like that. So they are properties of matter that depend on how much matter is available, or how much matter is considered. Is that okay? Yes. Like e.g., so these properties, extensive properties, are properties that depends on how much matter is available. E.g., so I've defined, that's how we define it. I will just give an example. So e.g., we can talk of mass, all right? Yes. So mass is one of the best example we can give, because you say, oh, this one has 2 kg. Okay. The other one is 5 kg. Would describe matter based on the amount that we have. Is that okay? Yes, that's what we call extensive property. But then intensive properties, they will just depend on like on how much matter is considered, not just like what is available. No. So here, for me to differentiate this, suppose I can say the best example I can say it's temperature. Is that okay? Yes. Temperature. Yes, temperature will be there because you say, okay, the temperature of the room is what? Temperature room is somewhere, let's say 25, 25. Yes, whatever. Yes, yes. So you find that all the rooms, not that because your room is big to change the temperature. No. Is that okay? The other property we can say is the color. The color of something. You can't say this color is what? It will be always green or purple. All right. We don't care whether they like um we don't care whether like we have, let's say, 20 liters of paint or what. Your room is painted, your room is very big. So long as it's painted with the purple, it is still purple. You get those properties like color. You get. Yes. So if we had to give me another example, if since I've like made it clear on extensive properties that actually depends on how much matter is being considered or available, then this one, they do not depend on matter available. Yes, these intensive properties, like your, what can I say, your blood, yeah, something like that. Yes, yes. So sure, sure. Those are the properties. In fact, I was supposed to say extensive properties, intensive properties. So they can be intensive or extensive. That's why we were just giving you examples, the physical, chemical properties. In fact, these are physical change or chemical change sometimes. Is that okay? Yes, I'm sure that's how you learn them. So there's physical, chemical changes. So then there are what you call extensive properties and intensive properties. Extensive property depends on how much matter is available. Suppose we have now 200 meters square. That's for area. And also the other one we have is, let's say, 100 meters square. We'll consider the what? The one which is, we are differentiating based on the difference in the what's this? In the amount available. But this one we are talking about now, just the property that holds the identity of something. The way we look at them, not just the way I mean something you can have. Hope I've made myself clear. Is there any question here? EG also, like density is one of the. Yes, it's one. Density is one of what? Extensive. So you have to figure them out like this. See, density will be always, what is the density of water? Sure, whatever water you have seen. So this is actually the overall, like it's a summary of something like temperature, your room temperature, human temperature, color. What's your skin color? Like your skin color is brown, you'll be brown always. Despite you gaining, you'll be always brown. Then also despite like changing the type of water, you still have the same density of water as 1 grams per centimeter, some stuff like that. So those you should master them like that. What if I ask you to say volume? Is volume an extensive properties or what? Why? Sure. So you find that you can't measure the volume of something and it's still okay. There's nothing we can measure to say it has this volume and that volume will be kept constant wherever you go. No, it changes with the shape, right? Yes, yes. Okay, those are the things. Otherwise, um, okay, that is it. So very important. Okay. All right. So let's go to what we call measurements now. Um, so these measurements are very important. Like this is where now as chemists we'll be doing. By the way, chemist is more of calculations as well. So yes, so it's important that we know how to measure. Even but for this topic is interrelated. Even in pH is also found measurements. So under measurements, we need to look at things like the SI unit of substances, the formulas, and also yeah, those are the things I think we need to consider under SI unit. So when you say SI unit, these are just standard international accepted units. That's what we call SI unit. They are accepted worldwide, like everywhere. You go to America, you find that okay, time is measured in second. You go to UK, time is measured in second. So they were just agreed worldwide. So these things, but a lot of measurements started from France. Yes, so that's how we'll be doing measurements. Like I'll be asking you things like, okay, what is the instrument used just for the sake of talking, just to remind like the knowledge that we left from secondary? What is the instrument used to measure volume in let's say milliliters? Yes, what instrument can you use to measure volume in that? Can use a beaker. Yes, beaker can also give. We can also use pipette. We can also use a graduated cylinder. We can also use volumetric, even burette. I'm sure like a burette one, that one which measure exactly 25 mils, something like that mils. So those are the instruments. So you also need. I mean, you need to know like the instrument used to measure mass. What's the instrument used to measure mass? All right. So even temperature. Okay. So temperature. Yes, thermometer can be used, and we need to know the SI unit. This is the thing that we need to talk about. Okay, so like this one, we use beam balance, right? We can use beam balance to measure this one. What can we use? Yeah, stopwatch. Yes, good. This one, thermometer, I've already said. So those are the things. Now let me take you. I just wanted you to recall these things. All right. So we start now in details. Like, all right. Okay, so the first thing that I'm going to say is just a moment. The network will strip a bit. Just a moment. All right, are you there? Okay, someone was calling, so my network was disturbed. Nevertheless, yes, I want to answer again. Sometime she can call, but don't worry. Like if it pauses, then I'll be back. I'll be back. Yes. All right. So we can start now. So we need to know again. Hmm? Hmm. Don't. Eh? Ah, we. Ah, you'd have, they are just, yeah, I understand. I understand. Someone they can be fetching water there. How much? Ah, there's no need. Then you're not washing. Kai. You would have even given them like, so okay, go wash him. I don't remember. Let them not do this. You see, tell them to say no 15 and I'm pay. We didn't pay the 10 that in if. Eh, not that name. Would have said would have fetched water. Hello, I'm on, this one is calling, but I'm on a meeting. Ah, well, okay, sorry. This person is calling, but I've texted them to say no. I'm in a meeting. She's busy calling. Emmanuel. Ah, Emmanuel. Yes, someone is busy calling. I've texted them to say no. I'm not. I'm in the meeting. You can't see a message. Okay, we continue now. Once again, she calls. I'll just cancel. Though the network will be disturbed a bit, but we'll continue. So, like I said now, let me just close the SIM card. Let me close the SIM card. Let me just close the SIM card. Mm. Hey, sir. Hey, sir. Hey, safe. All right. Okay. So now we start. Like we need to know the units just to recall. So the first thing that I'm going to say is, all right, what we call. I want you to tell me here. I will let's say the basic quantity. So the basic quantity. These are just quantities that actually do not come from different things. Is that okay? Like from combination of another quantity. There's what you call derived and basic. So the basic ones are the one you're actually making the derived ones. You add them or you do the manipulation, then you'll be able to get a derived. So here then I'll say name of the, okay, to come, just a moment. You tell me once it's actually there. Okay, let me, are you able to see? Okay, let me just do this. Good. Hmm? Thomas Raven. Oh, blind. So, okay, that is it. Then we say the name of the unit used and also the symbol there. Okay. So, what you're going to do is we'll say, um, I'm sorry, it is bent, but I'll try my best. Okay, so we'll have the name of the unit there, and also, so the first thing that we are going to do is, I'll list them like that. I'll start with the length. Okay, is that okay? So length, what do we use to measure length? Like length is measured in what? Okay, the standard is meters. Anything relating to distance, stuff like that is meters. Okay. Okay, so the symbol will be M like that, small letter M. Then the other thing that we can talk of is um mass. Okay, so these are what you call the base units. So mass, what is the standard units? No, it's kg. Like grams, just yeah for small things, but the standard world like accepted units is kilograms. Okay, I'll just say kg instead of me writing kg, and also here I'll just write kg because I can't write the kilogram. I'm like to waste my time writing over and over. So then the other thing that we need to talk about is time. What do we use to measure time? Like the SI unit for time is what? Okay, seconds. So but here I'll say small letter SI. Then the current, what do you use to measure current? Like the name of the unit? Amperes. Yes, amperes. Then what we do is I won't write ampere, but I'll just write A there, right? That's a symbol for current. Okay. Then amount of a substance is what? Amount of a substance. How do you call what do you call amount of a substance? Hmm? No, amount of a substance is called a mole. Let's say yes, let me just say amount. Sometimes you find it little in amount of a substance in some books. Okay. Then what will be the units? Okay, moles. Then here you just write the units. In fact, the symbol for this one, we use this when you are writing as units. Is that okay? Remove E. Yes. So then luminous intensity, that will be what will be the name of the unit? Okay. Yes, it is, please. So candela. So that means like we use the CD like that as the symbol. So these are what you call base unit. Most of things are derived from those two. From those seven we have listed there. Is that okay? I think I wanted to end with the prefixes, but I don't know if I can list, but did you do in physics? I think that is okay. Should I mention them or it's okay? Then we end. It's okay, right? I, yes, yes. Okay, can I ask you, what is the, as I'm concluding, what is the, I'll be giving you factors, right? Okay, so what is, let's say, 10 to the power negative 3? Yes, this is same as what? No, the prefix, yes. Okay, you are right in that, but I just want the name of the prefix. Okay, let me start. Let me start. When you see a number like when you see a number to say um 10 to the power 10 to the power 1, the power negative 1, this is what we call a des. Is that okay? So if you see a number like 10 to the power 2, like 10 to the power negative 2. This is what we call cent. That's why cent is just 1 over 100 centimeter. Okay. So if you, that's why you hear centimeter, it's a meter with the 1 over 100. It's more like, let's say I have 2 centimeter. This can be written as 2. This one is just a substitution of 10 to the power 2, which is 1 over 100. You have seen meters. You have seen. You divide that, you get 0 point something meters. So again, when someone tells you to say, what is the 10 to the power negative 3? This is what we call a milli. No, it's milli. Yes. Again, when you have 10 to the power negative 6, this is what? Micro, sure. So micro, you know even the symbol for micro. Then again, the important one is 10 to the power negative 9. What will be this? Sure, nano. Lastly, 10 to the power negative 12, pico. All right. So these are the things you need to bear in mind. These things you need to know them. Like, in fact, how you can use sometimes I can tell you to say let the following into its nearest prefix. Okay, 10 to the power negative 11. You see, what you're going to do is you move this point. You have seen that it's like this. The only closest a prefix you can use here, it's 10 to the power negative 12. So what you're going to do is you say 2 times 2, then the point you bring it there, then there it will be 12, right? Sure. So you light 22.3, then this one now you know the prefix use, it's what? Pico. So you say pico. You write P like that, the symbol is P. That's how you can express. That's how we'll be using them. Yes. You look at the closest one. If it was 9, you would have taken it again there so that you get the positive 10 or what. You look at what is closest. Then you will do the work on this one. We'll do some papers as will be. Yeah, even in physics, I'm sure you must be done with it. So those are the things I wanted to present, and this was just the introduction to chemistry, like we showed it earlier. I don't know for positive, please make sure that you understand these, especially the negatives ones. They like bringing the negatives ones. Okay. Yes, so those are the things. Otherwise, this marks the end for today. I think you go grasp some, follow those things you are jotting down, and we'll continue from temperature now into using calculator. Since you have now seen those prefixes, the positive ones and the negative, please pay attention to. Then we'll be able to do the conversions, stuff like that. So this marks the end. I'll post this video on YouTube. Sure. Okay. Have a good day. All right.